Sorry. So I hope I have shared a list of projects. Have you seen? Hello. My voice is audible? Not.
Hello, sir. You're audible, sir.
Okay, okay. I've shared a list of many projects based on transistor, right?
Yes, sir.
And there are a number of experiments which you can do, or small circuits which you can make with the help of transistor. Okay,
Okay, sir.
so you can ask and you can do the things if you want from their point of view. Let us come back to the topic actually. So in the last class, if you remember, this is what we did. You can see my screen.
Yes, sir.
Yes, sir.
Okay, so I hope you'll be able to understand the different current components. Okay, and thereafter we have derived the relation between this IC and IE in this case because this is common base configuration. Okay, the input characteristics as well as the output characteristics. So there are two kind of characteristics, that is input and output characteristics, right? So input means variation in the input side, keeping the output constant, output side constant, and here variation in the output and keeping the input side constant. So we have seen the characteristics. So this is how it is going to vary, and this because IC is equal to approximately equal to IE actually. Okay, so that is also reflecting here. Okay, so this cannot be used as an amplifier. Common base configuration can't be used as an amplifier. Why? Because in amplifier, what we need is, for any amplifier, the most important thing is its gain actually. Okay, means output must be that if input is 1 milliampere, output should be 10 milliampere. So gain must be greater than 1 actually. If it is less than 1, it cannot be used as amplifier, because whatever my signal is, it is, you are not enhancing it. इनपुट से आउटपुट जो है कम है, तो कोई फायदा नहीं उस सिग्नल का. इफ आउटपुट सिग्नल इज, सपोज दिस इज द सिग्नल, ये सिग्नल है मान लो, वॉइस सिग्नल है, राइट, एंड आउटपुट इज, अगर आउटपुट ये सिग्नल है, किसका एम्पलीट्यूड कम हुआ? हेलो,
Yes, sir.
if this red line is output and this is input, So this is an amplified signal or not?
No, sir.
Okay. Amplified signal should be like this,
Yes, sir.
right?
Yes,
So
sir.
that is what we have to see. Gain means हिंदी में इस gain को क्या बोलते हैं?
Lab.
लाभ, right? So gain should be higher. That should be greater than 1. Okay. So that's why common base configuration that cannot be used as an amplifier, but it can be used as a constant current source, right? Because IC is equal to alpha of IE in this. Okay. So now let us come back to a new topic. This class, that is, we talk about common emitter configuration. Common emitter means this one. This is the common emitter configuration. We are applying certain voltage here. This is suppose NPN. Okay. This is BBB. This is VCC. So, and if I talk about this voltage, this is base emitter voltage. Okay. But if I'm using a battery here or here, suppose these two places, these are batteries. Okay. So, representation of batteries like VCC. That means we have a voltage source. Battery as a voltage source here. That representation is always VCC. But if there is some drop, it is VVE. Battery is, you can see, battery कैसे represent की है? VV से. But if there is drop, it is base emitter. This is base, this is emitter. Okay, so that is the difference. If this is voltage, that means it is a drop. If it is this, that means it is a battery. That is how we are representing it. You might have seen, right? So this is one is forward wise and another one is reverse wise. This is what we are doing, and here the current amplification factor is beta. Beta, that is equal to IC by IB, or we can also say it is delta IC by delta IB. That can be means change with the help of that change. You can also find out. Okay, its value is usually higher than 20, right? 200. Its value is going to vary. So we know beta is equal to IC by IB. We also know that IE is nothing but IC plus IB, right? So I can replace this value IE minus IC, right? And beta is this one, or I can say that if I take this common, this is modified like this. So from common base configuration, we know alpha is IC by IE. So beta is nothing but alpha over 1 minus alpha. Right? So that is the relation between them. Or we can say beta is greater than alpha. That is how what we can predict. So and beta की वैल्यू 20 to 100 है and its value is alpha की वैल्यू कितनी है 0. That is less than 1. Okay, so this formula is also going to show this, that its value is also lesser. Okay, so as we know, IE is equal to IC plus IB, right? And if I replace it, it is alpha of IE we know IC is alpha of IB plus ICVO. And I replace this in the above equation, it is going to become if IC plus IB plus ICVO, then we have this 1 minus alpha of IC, that is alpha IB plus ICVO. Okay, IC is nothing but alpha over 1 minus alpha IB plus 1 over 1 minus alpha ICVO. So from here we can know, we can understand this is nothing but beta of IB, and this is beta plus 1 of ICVO. Because as beta is alpha over 1 minus alpha, beta plus 1 is nothing but, that is becoming 1 over 1 minus alpha. So we can replace this. Okay. So this is the equation being modified, and this is what we are getting. So this is the relationship for common emitter configuration. You can see this is so this can be further modified like this: beta IB plus beta plus 1. This is ICEO actually. Where ICEO is equal to beta plus 1 of ICVO. Because this is the leakage current because of minority carrier in case of common emitter configuration. And this is amplification factor. Okay, so that is quite simple to understand now, that these two relationships. So this is a relationship between CV and CC. So this is how. But important thing is beta and alpha here, and they are depending upon doping levels also. Okay, doping levels means free carriers, and free carriers they are going to decide the amplification factors. Free charge carriers, you can say. If they are less, so current will be definitely be less. If they are more, current will be less. It will be more. Now, if we talk about the input characteristics of this common emitter configuration, so that is quite simple. We know common emitter configuration. Okay, so so input characteristics we know the output must be we are just varying the input and we fix the output. Like this VCC we are fixing or this we are going to vary. So what happened is ultimately this one. Okay. 6 volts and this is PVE that is 0.512 like this. This is current because input current is that is IB is current. Okay, so we see here that this is NPN or you can say emitter, base, and collector. So input is here because this is forward bias, right? And this is reverse bias. Okay. This is common emitter configuration. That is what you can say. If this is forward bias, definitely junction J1 is small. But junction J2 is reverse bias. So what is going to happen is that we have this here. This is depletion layer. यहाँ क्या होगा ये डिप्लीशन लेयर जो है if you increase this VCC, okay, this depletion width is definitely going to expand, and this current which is coming from here going towards this side, so you know IE is coming, so base current is definitely going to come down because the base region is going to, as we increase VCC, okay, so VCE is increasing, and this cause of that depletion width is increasing, and because of the depletion width means base region is going to decrease, and when base region is going to decrease, definitely there is less recombination in this region, so base current is going to decrease also because base region is going to come down. That's why if you see here, as we are increasing this, as we are increasing this, so base current is going to decrease. The curve is turned on, or this device is going to turn on late. So that is how the input characteristics they are going to vary with the help of or by increasing this value. Generally, we are keeping it fixed, but if fixed value is higher, actually, that is what it means to say. So it is going to increase this, and if entire base region is going to be, means you are increasing it a lot. This BC is increased a lot, so base region can be destroyed, can be zero in fact, and that situation is called as punch through. ये आपने reverse bias को इतना बढ़ा दिया, this reverse bias, this is reverse bias, that situation is called as punch through. उसका नाम है punch through because base region is totally diminished in that case, and that is the problem with the BJT device over the years, that because of BJT's base region is very small, okay, and because of that base region very small, it is asymmetric device, and if you increase BCC, the reverse bias is increased, then there is possibility of punch through. No base region actually. Okay. So that is the problem, that nowadays BJT is less popular. As per present scenario actually. This is the only reason, that because it is of asymmetric device, and that is the problem with this actually. Okay, right? So BJT is a asymmetric device. All right. So if we talk about its resistance, dynamic resistance, or dynamic input resistance from this graph, then that is equal to delta VVE divided by delta I. And this VCE is constant. Okay, that is what we have to define. Similarly, if we talk about its output characteristics, Okay, so output characteristics, if we try to draw, that's quite interesting to understand that if I just draw here, so we are just varying this VCC, okay, and we are keeping this constant, right? So when VCC we are varying, definitely this VCE is going to vary, this IC is going to vary. So this is VCE, which is going to vary, and because of that, this IC is also going to vary, okay, and this IB is going to be fixed here. We can fix it 1 milliampere, 2, 3, like this, 0 से start करके. So if we talk about this one, so this is ICEO at IB is 0, because current equation is nothing but IC is equal to beta IB plus ICEO, isn't it? So if IB is 0, so IC should be, and this situation is cutoff edge. Okay, so this region of operation, if we talk about, this is nothing but, this is cutoff. Fine. IB value is 0. Now, if I increase this IB to 20, suppose, okay, so I'm saying this is IB is, suppose, 20 microampere, 40 microampere, right? So I can have partition between these regions. This I'll write 2 milliampere, this I write 4, this 5, this is 10, like this. This is in milliamperes. Okay, the value of beta that I increase up to 100. Okay, if beta is 100, so definitely it is in milliamperes. So this region is called as, what this region is, that is active region, and this region is called as saturation. This is called as saturation region. This is how we are defining it. Okay. Now the thing is that we have this one reason here, cutoff. This is reason 2, and this is reason 3. This is the third reason. Okay. ये सारा ये reason जो है वो that is cutoff or the saturation. Sorry. So we have 3 reasons: cutoff, active, and saturation. Here, cutoff means when IB is 0, IC is becoming ICEO. Active means base emitter junction forward bias, collector emitter junction reverse bias. That is the active reason. Means IC is equal to beta of IB plus ICEO. That is quite obvious. In case of saturation, base emitter junction and common emitter junction both have forward bias. Right? IC is becoming equal to less than equal to this. These are the 3 conditions we have. If you see here, saturation. Meaning of saturation means the output is not going to vary, or output is constant even if we change input. Here, input is base current and output is collector current. Okay, that means if we are varying the IB, and this is the IC, so this must be the active reason and this must be the saturation. Okay. So this is the saturation reason here, because here output is IC, which is constant. But this reason, if we talk about, that is varying linearly. That's why active reason is also called as linear reason or active. Okay, so IC is varying linearly, and you can say this is nothing but this is beta. This slope is beta because beta is nothing but IC by. Am I right? So here, this graph, if it is showing, so you can see when we vary the IB, it is this current IC which is varying here. That's why this region is active actually, because this is the input. So this graph cannot show कि this is a saturation region. है ना? This is active region actually. Whereas this left side, that is saturation region, because here current variation is very small. This variation, if you see, this is very small. Very small. These currents, they are very much close to each other. That's why this region is saturation. Okay. So this graph doesn't show कि active region कि IC, because otherwise यहाँ तो IC constant लग रहा है ना constant.
Yes, sir.
हाँ, but it is IC versus IB. And if this graph we see, it is IC versus VCE. So we cannot say IC is constant. It is constant with respect to VCE, not with respect to IB. So this is a current control device, current control, current source device. Right? Why it is not a voltage source or voltage controlled? Because ultimately all these things they are coming from these voltage sources. The voltage source ही है ना? Isn't it? But we are talking about IB, we are talking about this ICE, we are talking about this IC. क्यों जी? तो हमने ऐसा क्यों नहीं बोल दिया कि voltage? Why we didn't talk about in terms of voltage? So reason is quite simple, that because IC and IE they are depending upon doping levels, resistances. In fact, you can say input resistance and R input, R output. Okay, so this is to be determined, and because of that, the IC and IB or all these factors they are going to change. Okay, because of this resistances in this case. That's what we talk about in terms of IC and IB. And if you see the value of VCE, this is 0.2, like this, in saturation region. So VCE saturation very less drop here. Can you see? But it is 1 volt, 2 volt, 3 volt, up to 12 volts, like this. So in the saturation region, this is VCE saturation, and this is VCE active. Means drop across this junction. This junction is very less in case of saturation. And power dissipation across this device is that is VCE into IC. So VCE saturation is very small. So power dissipation is small when device is operating in saturation, isn't it? And it is large when it is in active region. And it is approximately zero when we talk about cutoff.
Cutoff region.
That is because ICEO current flow करेगा उसके इसमें. IB current is zero. Okay. So this participation is approximately zero in cutoff. And it is small in this case, saturation. So for digital applications, if we talk about, what we want is we want to turn on or turn off. Off means current should be zero. On means current should be maximum. Okay. So here saturation is going to give us that very high current, and this is giving us no current. So one is zero and another one is one, like this. Right? But for analog applications, like amplifier, it is the active region actually. If you see this one, means if This is increasing linearly in this region. 1, 2, 3, 4, 5, 6, like this. It is increasing linearly. So this is, we can say, this is in microamperes. This is in milliamperes. 1, 2, 3, 4, 5, 6, so on, like this. So this current is in microampere and this current is in milliampere. That is the difference. So that's why we can use it as an amplifier. IC is equal to beta IB. Okay, and that is in the active region. We say it is active or linear region. So we can use it as an amplifier. That's why common emitter configuration of the transistor that is used for amplifier, and that can be used for digital applications. So digital application, we know saturation, and this is important thing to understand, cutoff, and this is in the active region of operation. Okay, so this is a very key point to understand. This one. Okay, I hope you understand this point, because ultimately this is what we are going to use. We're going to use it in applications. Any questions now on this? Hello.
No.
Okay. हाँ जी.
डिवाइसेस क्या मीनिंग
हाँ जी, प्लीज रिपीट.
एसिमेट्रिक डिवाइसेस से क्या मतलब है
जो सिमेट्रिक नहीं है, जैसे ये सिमेट्रिक नहीं है ना, जैसे ये है. Sorry. Which one is symmetric among these two?
Upper one.
Because it has two equal halves. बराबर है ना? But they are unequal,
Yes, sir.
actually. So ये asymmetric है, ये symmetric है. Symmetry ज्यादा अच्छी होती है ना, isn't it?
यस सर
Yes.
क्यों? अगर सिमेट्रिक होगी, मान लो तरबूज है, तरबूज का
Yes,
शेप
sir.
पता है ना आपको कैसा होता है? कैसे होता है? इस तरह से रहेगा ना
Almost a sphere.
तरबूज, ऐसे लंबा सा. ओके, राइट. अगर ट्रक में डालना हो हमें, तो ऐसे ऐसे डालेंगे उसको, ऐसे रखेंगे ना. बट अगर
Yes, sir.
तरबूज का शेप ही ऐसा हो, ठीक है, तो पैकिंग कितनी आसान हो जाएगी, हो जाएगी,
Yes.
हो जाएगी ना ऐसे. एंड हियर इफ यू सी हियर, कितना स्पेस वेस्ट हो रहा है. ओके, या इस तरह से हो स्ट्रक्चर्स. बेंजीन रिंग देखी है ना आपने,
Yes, sir. Yes, sir.
तो इसकी पैकिंग भी कितनी बढ़िया है. ऐसा शेप देखा कहीं आपने प्रैक्टिकली?
Not fully.
honeycomb.
यस. ओके, तो वो कितनी सिमेट्री से बनाते हैं चीजें. नो स्पेस इज बीइंग डिस्ट्रॉयड बाय देम, है ना, कितनी बढ़िया पैकिंग टेस्ट है। और कितना स्टेबल स्ट्रक्चर भी होगा फिर, और ये कितना अनस्टेबल है। इट इज पॉसिबल बिकॉज ऑफ सिमेट्री एक्चुअली। ओके, दैट्स वाई जो बीजेटी है, बीजेटी आज की डेट में यूज नहीं होता इतना। इफ यू हैव योर मोबाइल फोन्स, देयर इज नो बीजेटी। मेजॉरिटी ऑफ devices is MOSFET, not BJT. Okay. Then we have common collector configuration. Right. So I'll share some diagram with you. Not going into much detail of them actually. This one. So if you see this, this is common emitter configuration. Uh, so this is small in this case. Okay. इस केस में है because input and output voltage they are almost same, right? Because of its very high input impedance, input resistance in this case, because input is common collector and base basically. Okay, and that is a bit of problem because base is least doped and collector is also lesser doped. So because of that, its input impedance is very high. Okay, that's why we have input and output voltage, they are almost same. Means whatever is the output voltage, that is the input. This is +4, this is -4 if you see. So that's why it is giving us unity voltage gain, or you can say this is a voltage follower circuit actually. right? So this is about common collector configuration, and this is input and this is output characteristics. There is one more file. I can show you this comparison. This is very important comparison. This one, right? If you see, this is for these applications. So for high frequency applications, common base is constant current source. We are using it. Common emitter is for amplifier purpose in general, or for audio frequency actually. Audio frequency range is 20 to 20 kilohertz, जो मैं बोल रहा हूँ basically. Okay, common collector is for impedance matching. Or in order to avoid the loading actually. Okay, this is constant current source. तो ये दो तीन तरह की applications हैं, but इसमें the most popular one is only common emitter. Reason उसका because reason is ये एनालॉग और डिजिटल दोनों एप्लीकेशंस में यूज होती है, डिजिटल में भी. Okay, any questions from today's class? Hello.
No.
Sure.
सर कॉमन कलेक्टर उतना इम्पोर्टेंट नहीं है क्या सर?
Actually, important तो डिपेंड करता है ना, व्हाट इज योर एप्लीकेशन एक्चुअली. ओके, काम वही है. इंपॉर्टेंट तीनों ही है अपनी अपनी जगह एप्लीकेशन पॉइंट ऑफ व्यू से, बट मेजोरिटी हम एनालॉग और डिजिटल एप्लीकेशन यूज करते हैं. सो कॉमन एमिटर इज यूज फॉर
एनालॉग एंड डिजिटल एप्लीकेशन.
हाँ, तो इसका सबसे ज्यादा यूज है बेसिकली. ठीक है, ये सिर्फ जहां लोडिंग से बचना हो. दिस इज ऑल्सो कॉल्ड एज एमिटर फॉलोअर because output is being followed by the input here. V output is equal to V input in this case. Basically, gain is 1. यहाँ पे भी दिया होगा ना. So, voltage gain is less than unity. In case of this, approximately unity you can say. And current gain is approximately unity in case of common base. So, that is the difference. इसमें क्या है, इनपुट इम्पीडेंस बहुत ज्यादा हाई होते हैं. If R input ज्यादा हाई है, so it can handle very large currents. कर सकता है ना?
यस सर.
Isn't it? रेजिस्टेंस
Yes.
ज्यादा, रेजिस्टेंस हायर रेजिस्टेंस होगी तो ज्यादा करंट को हैंडल कर सकती है.
यस सर.
ओके फाइन। तो इसका इम्पैक्ट है कि मान लो आपने माइक लगा रखा है, तबले वाले को भी जोड़ रखा है, गिटार वाले को भी जोड़ रखा है सिस्टम के साथ, तबला, 2-3 गाने वाले हैं, सिंगर्स हैं, ऐसे लगे होते हैं ना 8-10 स्पीकर्स।
Yes, sir.
दैट मीन्स लार्ज अमाउंट ऑफ करंट इज कमिंग फ्रॉम डिफरेंट सोर्सेज। अगर इसकी रेजिस्टेंस कम होगी तो I²R की वजह से ये बर्न हो सकता है। तो कॉमन कलेक्टर कॉन्फ़िगरेशन में रेजिस्टेंस हाई होती है, लेकिन जो V इनपुट है वही V आउटपुट की तरह आ जाएगी। ओके, और
Yes,
आउटपुट
sir.
रेजिस्टेंस है, तो मान लो यहाँ 1 एम्पियर करंट आ रहा है, तो ये डिफरेंट डिवाइसेस को दे सकते हैं, उसकी अपनी एक रेजिस्टेंस, डिफरेंट स्पीकर्स यहाँ पे लग गए, तो वो लोडिंग कम रहती है इसकी। सो दिस इज फॉर, क्योंकि इनपुट रेजिस्टेंस, दिस इनपुट वोल्टेज इज इक्वल टू आउटपुट वोल्टेज हियर, बट ओनली अगेन इज दैट वी कैन यूज मल्टीपल डिवाइसेस। कर सकते हैं कि
Yes,
उसी
sir.
से, हाँ, बहुत सारे नंबर ऑफ दिस माइक्रोफोन्स, और यू कैन सो स्पीकर्स, स्पीकर तो नहीं बोलेंगे इसको, माइक बोलेंगे, माइक, डिफरेंट माइक्स यू कैन यूज। तो इसका यूज ये है, राइट।
Yes, sir.
हाँ जी, और किसी को पूछना हो, अदरवाइज यू कैन लीव द क्लास।